So we're going to continue our lesson talking about imaginary numbers from class, and we're going to apply it to equations where we might get an imaginary outcome, and we're also going to learn about products of imaginary numbers. So quickly, imaginary numbers, by definition, are that I squared equals -1. Now we worked on simplifying square roots and working a little bit with square roots, which feeds nicely into this, so that we find that the definition for what I equals, we would have to square root this and square root this. So these two pieces cancel, and we find that I is the square root of -1. Now up to this point, this math has been impossible, okay? This is an opportunity where we would stop. But learning what we are now about imaginary numbers, we're going to be able to do some computation with numbers that now have a negative inside our square root symbol. So let's start off by looking at products of our imaginary numbers. We simplified things down in class. We looked at how to solve when we had a negative underneath our radical. So now let's look at how do we compute with these. So to find the products, we have two different situations we might see. We might see things where we already have it simplified down in terms of I, or we might see that we have square roots with negatives inside, and that's where we know we're going to need to use imaginary numbers. This is the easier of the two, okay? So here, we're going to start by multiplying our coefficients. So -5 times 3 is going to be -15, okay? To that, we are going to multiply our x's. Now, we're not foiling here, okay? We're just combining these terms through multiplication. Here we have an I times an I, or I squared. Now, if we think back to our definition of what an imaginary number is, we can see that I squared is equal to -1. So when we get this squared here, we can actually simplify that down to -1. So it becomes equivalent to -15 times -1. If we had I to the third power, what we would have is we would have a -1 on the outside and this piece as a remainder, okay? And we can do an example of that also. -15 times -1, to simplify this entirely and complete this product, we get a +15. So this is the answer to an equation like this. Just to sum up our steps for your notes if you want to write them down, the first thing we did is we looked at our coefficients and we multiplied them. We then looked at our I powers. They're being multiplied, okay? Our I values. Here we have an I times an I, so that gives us I squared. From our definition of imaginary numbers, we know I squared equals -1. So we just plugged in -1, multiplied it by our coefficient, and got a product of +15. So let's go through and actually start solving this problem. A property you might not remember from back in the day is that when you have two square roots and they're being multiplied by each other, just like here how we can combine them, we're going to combine these before we simplify. And then we're going to simplify like we did in class. So I'm going to start off by doing -6 times -15 is going to give me a positive. So I've already gotten rid of my I value because there's going to be a positive inside my square root. And 6 times 15 is 90. Okay? So now inside my square root symbol, I have a +90. Now again, to simplify or solve this, I want to get this down to the least terms within my radical symbol. So here I'm going to look, okay? I have 90, so let's do 9 and 10. I know 10 can break into 2 and 5, and 9 breaks into 3 and 3. So at this point, if I'm going to continue simplifying, I have no -1 to pull out, so there is no I at all. I have a set of 3's I can pull out. And then I have these two factors, these two prime numbers that are going to be left inside my square root symbol. So this is going to simplify down to 3 square root of 10. Okay. Again here, if I see that there's two square root symbols, I'm going to combine them. Okay? By multiplying, by finding the product of -6 and 15, I combined them, still under my square root symbol. From here, I'm going to break down, do my factor tree, get it all to prime numbers, pull out pairs, and then whatever factors are left are multiplied and left underneath our radical symbol. So simplifying our imaginary numbers is not just simplifying like this, but we can simplify using multiplication also. If we have i's, we're going to increase the power and then simplify it down. If we have square roots, we're going to combine them first. Here, it got rid of our I already. If it doesn't get rid of the negative symbol, then we would have a factor of -1, and then out here would be another I. Okay? And this would be as simple as this situation would get. So earlier I mentioned that imaginary numbers are also going to come into play with certain types of equations. Okay? So we're going to see that as we solve for x for these, we're going to end up with solutions that are going to be imaginary numbers. So here, this looks very similar to a difference of two squares with an x squared plus 100. However, obviously, it's a sum of two squares. It's not the difference. This is a situation where you are always going to get your solutions or your x-intercepts as imaginary numbers. So if we were to go through solving this, and we're not going to follow our normal factoring rules, we're going to just try to isolate our x as much as we can, you're going to see that it's going to end up being an imaginary number. So initially, if I have x squared plus 100 equals 0, to start getting x alone, I would subtract 100 from each side. In doing that, I'm left with x squared equals -100. Well, earlier we reviewed that the inverse operation of squaring is a square root. Our square root and our square cancel, and we're left with x equals the square root of -100. Right now, you can see that obviously we're going to get an imaginary number. We have a negative inside a square root symbol. Now, one thing that we have not applied to this yet is the idea of a square root. If we think of 9, okay, and the square root of 9, it could equal 3, but it could also equal a -3. And the way we write that is as a plus or minus 3, okay, which we write plus or minus 3. So as we do this solution, one of our x-intercepts, although it has an imaginary number, would be the positive version that would be squared to get this, and the other would be the negative version that would be squared to get this number also. So just keeping this in mind, let's go through and simplify this equation, okay? So we're going to figure out what we're going to do with this piece. We want a -1 out, and we want to take a 10. Excuse me, 100. The 100 then can be factored into 10 and 10, which is 2 and 5, and 2 and 5. So this can be simplified a lot. This -1 means that we're going to pull an I on the outside. So we have x equals I. Okay? We have a pair of 2's, and we have a pair of 5's. There are no numbers left, which means that there's going to be no square root symbol left in our simplification. Okay? Because there's a pair of 2's, I'm going to pull a 2 out. And because there's a pair of 5's, I'm going to pull a 5 out. Okay? So really, x equals plus or minus, because it could be the positive version or the negative version, of 10i. Positive 10i squared will give us this, or negative 10, which would be our positive 100 times our square root of -1, would give us this also. Okay, so it's a plus or minus as a solution here. This plus or minus should always come into play as you are solving, especially equations. Okay, you need to add that plus or minus because there are two possible solutions every time there's a square root. One of them could be a positive solution, one of them could be a negative. I switched up our second example, so it's going to be a little bit easier to work with and it'll make more sense to you. So we're going to keep this work to the side. Again, here we see that it's kind of like a difference of two squares, except that we have a plus sign. So to get x alone, or to solve for our x, find our solution, we're going to isolate it. So we're going to subtract 64 from each side. Okay. And clearly standard notation would have a 0 there. We're left with 4x squared equals a -64. Divide by 4, divide by 4. So there's that extra step here that we didn't have because we had no coefficient in front of our squared. Those cancel. We're left with x squared equals -4 goes into 6 once. There's 2 left over. 4 goes into 24 6 times. So we're left with a -16. I'm going to square root. Those cancel. I'm now left with x equals the square root of -16. We need to simplify that more. We want to change everything into terms of terms of I. So I'm going to factor this. I'm going to take out a -1, and I'm left with 16. 16 factors into 4 and 4, which are perfect squares. At this point, you could say, okay, I know I'm going to pull out a 4. But if you weren't there yet, you'd see this comes into 2 and 2, 2 and 2. So from each of these pairs, I will pull out a 2. This -1 becomes I. So my answer to this, okay, my simplified version of this equation, or my solutions to my x-intercepts, are going to be that x equals this negative 1 inside our square root sign becomes I. We have a 2 we're multiplying from this pair, and we have a 2 that we're pulling out from this pair. So if you simplify that, 2 times 2 is 4. We're going to end up with 4i. Okay? Again, because it's a square root and we're getting solutions, if you think about it, this quadratic could have 2 solutions. Okay? We need to make this not just 4i, but a plus or minus 4i. It could be the positive, it could be the negative version. Either way, when it is squared, we are going to get our negative 16 inside our square root symbol.